Hello. In this video, I want to take another look at example 4 in your book from section 6.4. In this problem, we're given the value of sine of theta, and we're told that cosine of theta is negative, and we're asked to find the values of the other trig functions of theta. Now in the book, the way they solve this problem is by using the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. They're solving for cosine of theta, so first they solve it in general for cosine of theta. Then they know the value of sine of theta, so they plug that in, and then they're able to solve and get cosine. From there, they use the quotient identity and the reciprocal identities to find the values of the other trig functions. Now, another way of solving this problem is by using right triangle trig, like you did in section 6.2, and I actually like that method better. Because it ties into what you've learned before, and I think it's simpler. So the method I'm going to show you works for any problem where you're given the value of one of the trig functions of theta, and you want to find the others. And also keep in mind that these kind of problems will occur throughout the book. We'll see them again in chapter 7. Okay, so let's start over on this problem. We're told that sine of theta is 4/5, cosine of theta is negative. Okay, now, before we do anything, because sine of theta is positive, that means we know that the y value is positive because sine of theta is the y value. Okay, cosine of theta is negative, and so that means the x is negative. So when we draw our triangle, we know that the y value is positive, so that means we need to be either in quadrant 1 or quadrant 2. But the x value is negative, so we must be in quadrant 2. In quadrant 2, the x's are negative and the y's are positive. Okay, so I'll draw my triangle in quadrant 2. Now I'm given sine of theta equals 4/5, and remember from section 6.2 that sine of theta is opposite over hypotenuse. So on my triangle, I can label the opposite side 4 and the hypotenuse 5. And once I know two sides of the triangle, I can use the Pythagorean theorem to find the third side. I'm going to call this x. So the Pythagorean theorem says x squared plus 4 squared equals 5 squared. And we solve for x. So x squared plus 16 equals 25. Subtract 16 on both sides. X squared equals 9. And then we take the square root of both sides, and we really get x equals plus or minus 3. But looking back at our triangle, remember that we're in the second quadrant, so the x is negative. So x equals negative 3. Okay, now that we've got our triangle all labeled, it's really easy to go back and find the values of all the other trig functions. So cosine of theta is adjacent over hypotenuse. So looking at our triangle, the adjacent side is negative 3 and the hypotenuse is 5. So cosine of theta is negative 3/5. Tangent of theta is opposite over adjacent. So opposite is 4, adjacent is negative 3. Okay, so tangent of theta equals negative 4/3. And then the other trig functions are just the reciprocals of those. Okay, so I really like this method better. I think it's simpler. When you draw the triangle, it helps you remember what your signs need to be. Okay, and it can apply to any problem where we know the value of one of the trig functions and we want to find the others.